Thank you so much for the opportunity to present our research. I'm excited to tell you about our findings from the Speak Out data. I'm going to zoom in here. So the first thing to know is that people with Parkinson's present with hypokinetic dysarthria, which is characterized by reduced loudness, monotone pitch, and articulatory imprecision, and that impacts their intelligibility. The Speak Out Therapy program cues patients to speak with intent or purposeful and deliberate cognitive focus on increasing attentiveness to speech production. Allison Behrman and colleagues found that following a course of Speak Out, they observed gains in intensity, prosody, voice quality, and voice related quality of life. But these parameters don't address the articulatory component of speech production like vowel dispersion metrics can. So we asked, what does Speak Out do to vowel dispersion metrics? And what percentage of people demonstrate an increase in these metrics following Speak Out participation? We used vowel space area and vowel articulation index. And the key difference between the two is that VSA measures the absolute area of the vowel space, but VAI is normalized, so it's less sensitive to individual variation. The bigger VSA or VAI are, the more distinct the vowels are. The more distinct the vowels are, the more intelligible their speech gets. We also used the same data from the Caterpillar Passage in Behrman studies in 2020 and 2022. There were 40 in the Parkinson's group, and we received 6 from the control group. We annotated the corner vowels e, a, ah, and oo, and then we applied these formulas to calculate mean VSA and VAI from each participant's formant values. This is what the annotation looked like in PROT. There's the waveform, the spectrogram, and the 2 tiers for annotation. We used the Tukey HSD test for significance, Cohen's D for effect size, and we calculated the percentage of participants who demonstrated dispersion that increased. And these were the resulting quadrilaterals. The dotted line represents the E, A, Ah, and U, the corner vowels of the control group. The orange represents the corner vowels of the Parkinson's group before participation in Speak Out. And the blue is after participation in Speak Out. Right away, we notice that the blue vowels are much more spread apart than the orange, and the orange is a little bit smaller than the dotted and a little bit to the top and right. And that indicates that from pre to post, we see an increase in vowel distinctiveness beyond our control group's productions. Here are the p-values and the effect sizes. We can see that VSA and VAI pre to post were significantly different, and the effect sizes were large. At the bottom here, 88% of the participants improved in VSA, while 90% improved in VAI. This figure sums up our statistical results where the orange is pre, blue is post, gray is control. The pre-post difference was significant for VSA and VAI. What does this all mean? Speak Out participation was a significant predictor of increased vowel distinctiveness, and it showed us a big effect on the separation of vowels. In fact, our participants overshot the control productions. Also, only a percentage of our participants demonstrated an increase in vowel dispersion, and there was a mismatch between the percentages for VSA and VAI. So we should look at individual variation in responses to therapy. Additionally, I'd like to know if hyperarticulation makes these participants sound more or less natural. We're limited by the fact that we used read speech instead of conversational speech, or if hyperarticulation like this compounds into the fatigue that our patients with Parkinson's experience typically. And finally, I'd like to know how well our vowels line up with the other acoustics that Behrman et al. Observed. Again, thank you so much to the Parkinson Voice Project for providing the data for our study. We are believers in Speak Out at our clinic in Utah, and this just gave us more empirical evidence to have hope in Speak Out. Again, thank you so much.